Hello everyone. So today we'll start with assembly module. So to start with assembly, I'll go for files, new, and now here assembly. Say OK. So here is the starting interface of the assembly. You can see here, this is the starting interface of the assembly. Here you have unit selection, same as part modeling. First we will select the required unit of assembly. Next, here it is given the model tree area. Here is the UCS, user coordinate system, which is used to show the required working planes. So you can see here the common things are that here also we are having one origin, front, top, right plane. Next thing here is you have to call the components by using this tab, insert components. So to start with assembly, I'll go in insert components, select the insert components option, and from there you can browse the files here. The icon is given here, or by default this page will pop up so as to browse the part as required. Suppose I want to say browse here, it will again direct to this page, and from here you can browse the required part you want to assemble. So we'll start with browsing parts. In desktop, I've saved my parts in this Rathore Sagar name folder. First I'll call this whole plate here. I'll select the part, say it open. Now the first part has been inserted here. I just need to click on the screen. This part is placed as a fixed part. You can see here, this icon will represent the part. This F icon will represent that part is fully fixed. You cannot drag and move the part here. But if you hold the cursor and then drag, it will move. But actually it is in fixed condition only. So if you drop the cursor and then drag, it will not move from its position as it is a fixed part. So to make this part float, I'll right click on the part and say float command. So after saying float, this part will start moving and floating here. There is a purpose behind doing this. It is because we have to make the assembly origin being coincided with the first part origin. Press the control key and now you can see both the origins in blue color here. Both the origins are apart from each other. So I need to match both the origins by using mates option. So in assembly we are going to see multiple categories and types of mates by which we are going to assemble the required parts. So before understanding the assembly, we are going to see what are mates. So you can see the icon here. One pin icon is given named as mate. So I'll select this mate category here. So in mates, there are certain types of categories given. First one is standard, second is advanced, and third is mechanical. We are going to go through all these three categories. But what are mates? Mates are nothing but the relations or commands which are going to be used for making one part lie on another part and make a combined assembly. So mates are nothing but relations that we are going to apply between two parts or multiple parts so as to make a combined assembly. So to start with mate, today we are going to start with standard mates. So in standard mates, there are total 8 categories given here. First one is coincide, second parallel, third perpendicular, then tangent, concentric, lock, second last with numerical value, that is distance mate, and the last one is angle mate. The last two mates will have the numerical values here so as to apply the required mate. Now before starting with the mates, you can see here the front, top and right plane of assembly are showing separately from the part, and if you select the parts front plane, top plane and right plane, they are apart from the assembly's planes. So to work properly with center planes, we will combine all the planes. For that, we need to combine the origin of first part and assembly. So for combining the origins, we will go for mates option here. And now we will select assembly origin and the first part origin. Now this part is moved towards the assembly origin and coincide mate is been applied here. You can see at this upper side, all the applied mates will be shown here. This part was moved towards the assembly origin. It is because firstly we have made this part float in condition. Suppose earlier if we have kept this part fixed only, then this mate would have shown error here as this part would have not been moving here. So it is compulsory for the part to make in float condition and then only go for mates option here. Now the coincide mate has been applied here. I'll say it OK. And now we can see front, top and right plane of assembly are combined with front, top and right plane of first part. You just need to combine the origins of assembly and first part so as to combine all the planes. It will make us easy to assemble the parts with center references. That's why we have done this process, and it is done only for the first part. The further parts will not require this process. After meeting the origins of first part and assembly, now we will call the second part here. For that I'll say insert components and I'll call the shaft plate here. Now I need to assemble this shaft with the hole. For that we'll go for concentric mate. As both the surfaces of the shaft and hole are circular in nature, for that we'll go for concentricity. Concentricity means matching the centers or axes of circular parts that may be hole or a shaft. For that I'll select mates option here. Select the outer circular surface of the shaft and circular face of the hole. You can see by default system is taking a concentricity mate. If you want to flip the orientation of the part, you can click on this option, flip mate alignment. This option is also available here. If you want to click here, you can flip the alignment by clicking on these arrows, or else you can flip the alignment by clicking on this option also. I'll say it anti-align and align. So this option is used to flip the parts here after making concentricity or any mate. I'll say it okay. So the second mate I have applied here is concentricity. Now you can see I cannot move this part in Z and X directions as the mate concentricity has been applied here. Only Y directional movement is been on and the rotational movement of the part is on. So to constrain all these rotational and axial movements, I'll go for another mates. I'll say parallel this face and this particular face. Again say it okay. And now the parallel mate is been added between these two faces. That's why both are in same alignment. So instead of going for parallel mate, you can also go for coincide mate. Suppose this part is position incline here. Again I'll go for mates option. Select both the faces. System will by default take coincide mate. There is very slight difference between coincide and parallel mate here. Say it okay. And now both these faces are being coincided. In mate history I can see three mates are being applied. First one was origin with origin. Second was concentricity between the hole and shaft. And third mate was coincide. Now only one movement is on here. That is Y directional movement. So to lock this Y directional movement, I will have two options. I'll select the mate option here. Suppose if I select flat faces here, it will by default go for coincide mate. Means these two faces will be coincided here. Next, suppose if I delete this coincide mate between two faces, again this movement is on, then I'll go for distance mate here. Select the mate option. Select both the required faces. You have to be careful while selection of faces and edges. Here the edge is been selected, so I'll clear the selection. Again go for selection of faces. System by default is taking here as coincide mate. I'll say I don't want coincide, I'll go for distance mate. So for applying distance mate, you just need to click on the symbol of distance here and apply the required distance between two faces. So I'll go for distance of 50 mm between two faces here and then say it okay. Now all the motion are constrained between two parts, and here the assembly is showing as fully defined. So for constraining all the three motion X, Y and Z as well as the rotational movement, you need to require at least three mates here. First one was concentric, second was coincide and third was distance mate. Now you can see here we have given coincide mate. So this coincide mate was given to lock the rotation of the part. Now to lock the rotation, there is one more alternative way. We will delete this coincide mate. The rotational movement is again on here. The part is rotating. So instead of giving coincide mate between two faces to lock the rotation, we can also do one thing here. That is, we can edit the concentric feature. Say edit feature, and in concentricity while applying the mate, you are having one option here to lock the rotation. So I'll on this option and then say it okay. Now lock rotation is on. This part will not rotate here. The concentricity was given here and that concentricity was locked now. That's why this part is not moving. So instead of giving coincide mate between two faces, we can also do here is lock the concentricity of that part. That part will not rotate again. Again I will go for unlock rotation. You can lock and unlock rotation just by right clicking on the mate and saying it unlock the rotation. Again, this part is rotatable now. You can see the symbol difference here. Both the circles are showing a plane circles. Suppose if I lock the rotation by right click and say lock rotation, the inner circle will show as a dark circle. Again, unlock rotation. Now the circle is not showing dark here because the rotation is unlocked. But suppose if you want to again lock the rotation, just right click and say lock rotation. But the drawback of concentricity made being locked, that the position of this plate is not defined. It may be inclined or parallel, perpendicular. In any position it may get locked. That's why it is better to unlock the rotation again. And previously as we have provided coincide made, again we will go for coincide made only. Select both the face again and then say coincide. Again these two faces are coincided with each other and the part is positioned in a linear way correctly here. Say it OK. Now if you want to copy any part, you just need to hold the control key continuously and drag the part. This part will be copied here. You just need to hold the control key and then drag the part. So you can see multiple copies of that part are being applied here. I just want one copy, so I'll delete this part. Now if you want to see the difference between coincide and parallel here, these both mates were close to each other. So if I want to see the difference between coincide and parallel mate, then I'll make this part little bit inclined. For that I'll go for rotate component here and I'll disturb this part and make the position here as inclined. Say OK. First we'll coincide both the top faces. And now to see the difference between parallel and coincide mate, I'll select the mate option. Select both the faces here, both the side faces. Now the mate been applied here is coincide mate. So in coincide mate, both the faces will be parallel and will be both attached to each other. I'll say it OK. Now you can see here both the faces are parallel and are connected to each other. I'll undo this mate or delete this mate again. That is the last coincide mate between two side faces. I'll delete this mate again. And again I'll make this part a little bit inclined here by rotate command from this move component option. Now we will do parallel. First we have given coincide. Now I'll go for parallel. You just need to see the difference between coincide and parallel. Select the mate. And instead of saying coincide, I'll firstly select parallel mate and then select both the faces. You can see both these faces are being parallel, but they are not attached to each other. So in coincide mates, these faces will get attached to each other, and in parallel mate, two faces will become only parallel. They will not get attached to each other. So this was the main difference between coincide and parallel mate. I'll say it OK. Now instead of parallel, I want to apply perpendicular mate here. For that also, I'll delete the parallel mate and then go for perpendicular mate. Select the mate option. Select the perpendicular option. You can apply perpendicular mate either between edges of two parts or faces of two parts. So I'll select the flat faces here, this side face and this side face. Now you can see both the faces are perpendicular to each other. That is, they both are at 90 degrees to each other. Say it OK. Now again we will revise the distance mate here. Now suppose I want distance between these two faces, this face and this face. Select the mate option. Select the distance mate here. You have to keep note that distance mate, parallel mate, perpendicular mate or coincide mate. All these four mates will be applied between flat faces only. Maybe faces, maybe planes, maybe edges, but they should be linear and flat. I'll select both the faces again. And for distance value, I'll put up the distance mate here as 60 mm. So these two faces are 60 mm apart from each other now. Say it OK. So we have revised the distance mate again here. Next, I'll take copy of this bottom plate part to apply the angle mate. For that, I'll go for mate options. Select the required edges to coincide. I'll coincide the side faces also. And now you can see the part movement here. It is rotating in all 360 degrees here. So if I want to make an angle made between these two faces as 45 degrees angle, I'll select the angle made here, select both the required faces and provide the required angle. I'll say it 45 degrees here. I'll flip the dimension and flip the orientation of the part. So you can place this angle made in all four quadrants just by flipping the dimension or by flipping the mate alignment. You can see here. Now it is in fourth quadrant. Again it is in first quadrant. For second and third, I'll flip this part alignment. For third quadrant position, I'll make this orientation flipped here. Now it is in third quadrant. Again say flip dimension. It is in second quadrant. So now it is taking 45 degrees here as an angle made. Say it OK. Now the next mate we are going to see here is tangent mate. For that I'll call one part. So I'll call one cylindrical shaft here. Now I want this shaft to be placed on this flat face. The cross section of this shaft is circular in nature and this face is flat in nature. So if I want to place this shaft on the flat face, I need to apply the tangency made. For that, select the made option, select the circular face and flat face. You can reverse the selections. First you can select the flat face and then circular face. Either ways you can do this made. Now say it OK. Before saying it OK, you can see here, if I want to flip the direction of tangency, there is one option given here, that is flip mate alignment. So I'll select here flip mate alignment, and this shaft now is coming here in between at lower side of the surface, but it is still tangent to the surface. If I say OK and drag this part away, suppose it is not selectable here. If you are not able to select here, you can do one thing is select the part from model tree and then drag the part here. Now you can see this part. It is away from this face, but it is still tangent to the face. So if I drag it here again, you can see the tangency of that circular face with the upper flat face. Again, if I want to flip the direction of the tangency, I'll go in mate, select the tangent mate, say edit feature and flip the tangency here. Say it OK. So now this part is tangent with the plate and kept on the above surface of the plate. And now suppose I want to place this shaft with this orientation at center of the plate. So it should have equal distance from both the sides, from left side and right side, and it should be placed in center. For that we can do here is select the mate option and we will select the assembly plane here, this right plane. As we have matched the assembly's origin with first part origin, the planes are coming in center. That's why I have selected the right plane here. And then go for the parts plane, similar plane of part. That is this top plane. We can select this top plane also or this right plane also. So I'll select the top plane with the assembly's right plane. And now both the planes are coincide with each other. You can see here. And as they are coincide, I'll select the edit mate feature again to show the reference plane. As both the planes are coincide with each other, this part is locked with the center plane of the assembly and it will not move either on right side or left side. It will by default come on the center orientation. So if you are having circular parts, you can match the center planes of the parts with the assembly planes so as to orient in center. Now again, the second way of orientation in center is, suppose I want this part again to be oriented in center with reference to this distance now. I want this part to be placed in exact center. So I'll calculate the distance first. So to calculate the distance between two faces, you can do evaluate, go for measure command and select the two reference faces. I'll select this face and the other face. You can see one scale mark is coming here instead of arrow. That is for selection of the faces. I have selected both the faces and it is showing here the 100 mm distance. You can see here the distance it is showing 100 mm between these two faces. I'll exit this. Again evaluate and measure the distance of the shaft now. We will select both the faces here. And now the distance of the shaft it is showing as 50 mm. So I'll do some calculations here. I know that the distance of this plate here, it is 100 mm and this is 50. So I'll minus this 50 from this 100 mm. So the result is again 50 mm. And suppose if I want this part to be kept in center from both the side equal distances, then I need to select these distances as 25 mm from one side and 25 mm from other side. So the second option here to orient it is by giving distance mate. I'll go for assembly again, select the mate, and I'll apply the distance made between these two faces, that was 25. Say it OK again, and now this part is completely placed between the center of the plate, horizontally also and vertically also. So for vertical orientation we have used plane option, and for horizontal orientation in center we have used distance command. Now suppose I want to edit this part. If you are already in assembly and still you want to edit the part, you came to know that part is not of the required distances or sizes, then you can edit the part in between assembly also. For that, select the part. One chart will pop up here. You just need to select open part option here, the first option, or the second option, open part in position. Both options are useful. I'll go for open part option here. And now we are redirected to part modeling, in which this shaft is open again. So it is a part modeling interface here. I'll edit this shaft. You can see the model tree of shaft been made here. So I want this length to be increased. Instead of 50, I'll say it's 70 mm. And then update the part. You have to rebuild. You have to click on the rebuild option here. Now the shaft length is updated here. You compulsory have to say save here. Control save. Next, close the part. It will automatically get updated here. Now you can see the length of the shaft is 70 mm. First we have used 25 mm distance to place this shaft. Now we will again recalculate the distances. So this was 100 mm. The updated value is 70. So 100 minus 70 is 30 mm. Divide by 2, that is 15 mm distance. So I need to change the distance made here. I'll go in made history again on left side of model tree. Say distance made, edit feature. And instead of 25 mm, I'll say it 15 mm this time. Again it will get oriented in center of the plate. Say OK. So in this way you can edit the part in between assembly also. You just need to click on the part and say open part, re-edit the part, save the part, and again redirect it to assembly. The next and last mate we will see here is lock mate. Now for lock mate, I'll drag copies of this part here. Now both the parts are individually moving here. I'll go to mates option, select the lock mate and select both the parts. Say it OK. Now you can see lock the two components together mate has been applied here. Say it OK. Again OK. And if I drag the first part, the second part will move with the first part because of lock mate applied here. This was lock mate. It is used when you are having two parts that are to be moved relatively with each other. That time you can apply this lock mate. So this were the standard mates given. We have seen and gone through each mate here. We'll stop here.